Hello, everyone. Thank you so much for joining us for this talk on AI explainability and trust. So my name is Bushra AlAhmadi, and I have recently finished my dissertation for my PhD in cybersecurity at the University of Oxford. I'm also a GDG lead in Oxford, where I'm currently based in the UK. So here's my Twitter handle at Bushra AlAhmadi if you have any follow-up questions after the talk. Please feel free to write your questions in the chat area here, and I will be taking your questions at the end of the talk. So what we'll do in this talk is that we will discuss how we can ensure that ML product decisions are really human-centered. So how much should your user trust the ML system? And what are the ways that you can show the user the confidence that is associated with a prediction of your ML products? So we will also discuss ML prediction explainability and user trust to produce ML products where users know when to trust its predictions and when they should apply their own judgment. So during this week, as part of MENA Digital Days, you hopefully had the chance to learn about ML and how you can start building ML models for various applications. And as we all know, ML is really already driving everything from things many of us are used to, like recommendation engines, but also to really high-stake use cases like autonomous vehicles and cars. So this talk is not really a crash course to ML, but I just want to quickly introduce a few concepts just to make sure that we are all on the same page. So for example, if we have an image classification problem, and let's say we want to classify images to either a cat or a dog. So here our data set is a collection of images of cats and dogs, and we might want to use a deep neural network that classifies these images to either a cat or a dog. So for our neural network, the input to the network is the raw pixels of the images, and the output of the network is a classification, so whether the image is a cat or a dog. So we have the input layer and the output layer, and we have a number of layers in between that represent artificial neurons. So these are loosely inspired by the way the brain works, but it's more appropriate to think of them as simple mathematical functions. So these neurons really represent mathematical functions. And they also have a weight associated with them. And initially, the weights are random, and the network won't accurately classify these images. And during training, what we do is adjust the weights using the algorithm called backpropagation. So here we trained an ML model to classify images to either cat and dog, and thus providing us with a prediction, which in this case, in this example, the prediction is a dog. So when we think of how we are building ML products, it's usually as follows. So first, we collect the data and label them. So in the previous example, we have a collection of images of cats and dogs that are labeled. And then using these data set, we build and train the model and then evaluate using evaluation metrics. So we might use metrics like accuracy, F-measure, precision, recall, and there are many more. But we need to use them to evaluate how well our model is doing. And once we are happy with a model performance, the model is then deployed and used to generate predictions. So in the previous example, it provided predictions of whether it's a cat and dog or a dog, and it might give you a score. And this score represents the prediction confidence, meaning how certain is the model of the prediction it is providing. So hopefully you kind of have now a little bit of an understanding of how ML works, and maybe you have tried your hand at training your own ML models. But what does it mean for users of the feature or product which is driven by machine learning? So if you are building a machine learning feature or pushing out a machine learning feature in one of your products, what does it mean for the users that are going to use that feature? So it's one thing to go from this to something like this. So from our previous example, What if we were to productize that model and turn the image classifier to an app? So going back to how we build ML models. So if you think about it, we really are the ones who are choosing the data sources. We are the ones that determine the evaluation metrics that are used to evaluate the model. So whether we're using precision, recall, F-measure, and so on. And all of us get affected by the results. So imagine in the future, you want to train a more complex model. Say you want to train a model that recommends whether a doctor should operate on a patient, or whether a person should buy or sell a stock, or even something more mundane, like recommending which is the fastest route to take on your drive home. So it's very important to think about how you communicate the confidence of your model predictions to the user and the reasons why it makes its decision, because that prediction will impact the user. So if we're building an app where the doctor would use to decide if it should operate on the patient, the recommendation or the prediction provided by the app, not only does it affect the user, which in this case is the doctor, but also has high impact on the patient. So again, we have to really think about how we can communicate the confidence of the prediction to the user and why it's making its decision, because it will impact them. And that's where human-centered AI comes in, which is really the focus of this talk. So as more and more experiences are built into ML, it's very critical that we, as product creators, designers, developers, ML experts, actually understand the role we play in making users feel in control of technology. Because really, machine learning is new to the general public. They might not understand what machine learning means, or what it's not capable of, and how should the users interact with it. So as we are incorporating more and more machine learning into our product features, we want to make sure the users feel in control of the technology and not the other way around. So again, what we need to do as product creators, designers, developers, we need to understand how the machine learning-based feature impacts the users and how they interact with it, and not only just focus on how we design the models and how many layers and so on. So that's one aspect of what we mean when we say human-centered AI, especially given the general public misconception and understanding around what AI or machine learning even is. So Google has a team called PAIR team. So PAIR stands for People Plus AI Research. They do research and design of people-centric AI systems. Because really, it's not just about the technology, but about the impact it has on us as humans. So PAIR has developed research tools and resources for building human-centered AI products, such as the People Plus AI Guidebook, which they launched in May 2019 at Google I/O. So what the guidebook is, it's an open source framework that you can use to make AI product decisions that are very human-centered. So it helps you ensure that the time and resources you invest in building AI make a big impact while putting the user first the entire time. So the guidebook has 6 chapters, which cover everything from how to identify user needs. So in other words, should we ML this? Should we use machine learning for this feature? To acknowledging that your machine learning models will fail. So how can you design graceful paths forward for your user in spite of that? So each of these chapters will provide some guidance on how you can center your machine learning feature design around the users. And so due to our limited time together, we're just going to focus on just one of these chapters, which is explainability and trust, through some discussions and examples. So let's talk about explainability in AI. So AI-driven systems are based on probability and uncertainty. And the right level of explanation is key to helping users understand how the system works. So once users have clear mental models of the system's capabilities and limits, they can understand how and when to trust it to help accomplish their goals. So in short, explainability and trust are inherently linked. And we want to focus on how our users need to make decisions based on the predictions of our models, which boils down to these key concepts. So the first one is, how much should your user trust the AI system? And what are ways to show the user the confidence associated with an AI prediction? And you might notice that the second question is grayed out, and that's because if you go to the guidebook online, they go deeper into this, but for purposes of time, we're only going to focus on those two topics instead. So when you incorporate machine learning features to your products, your users will need to make decisions based on the predictions of your model, right? So for example, let's say you are building a mobile app for the visually impaired that uses image classification models to enable them visually to search their environments and surroundings to determine how they should navigate and where should they go. So their decision on where to navigate depends highly on how much they trust your machine learning feature. So let's talk about a little bit about the trust spectrum. So on one end, you risk your user having no trust. Say they don't know where this prediction or recommendation is coming from, so they'll just ignore it. On the other end, if the user assumes that the system always knows best and they don't question it, then you risk your user having too much trust. And because AI products are based on statistics and probability, the user actually shouldn't trust the system completely. And what we want is to help our users calibrate their trust. So based on the system explanations, the user should know when to trust the system's predictions and when they should apply their own judgment. So how can we calibrate trust? So to build calibrated trust, there are 3 questions that you need to ask yourself and discuss it also with your team. So let's walk through each of these. So first, what are the stakes? So we need to consider the situational stakes of the user experience. For example, for an AI-driven navigation app, it may not be necessary to explain how arrival time is calculated for a daily commute. However, if someone's trying to catch a flight, it's higher stakes and less frequent than a daily commute. They may need to cross-check the timing of the recommended route. So in that case, the system should prompt them with an explanation of its limitations. For example, if a user enters the local airport as their destination in, let's say, Google, any navigation app, that navigation app should let them know that traffic data only refreshes every hour. So it should tell the user the limitations of that prediction. So there are other things to consider when we talk about situational stakes. First of all, what are the consequences if a user overtrusts the recommendation of your feature? And the second one is, what about if they ignore a recommendation based on previous experiences? So if you're providing a recommendation for the navigation app, what would be the consequences if the user overtrusts the recommendation of the feature? And how about if they ignore a recommendation? So let's give you an example. So let's say you want to build a workout or a running app, and your user is exercising after an injury, and is using your recovery workouts recommendation feature so that the app can recommend him or her a workout that they can follow after that injury. So here, the user really needs confidence in the app's recommendation. So I'll ask you this question. From these two applications, which of these recommendation designs should we aim for? Do you think it's the left or the right? And write your answers in the chat, and I'll give you a little bit of a moment to think about this. So which of these screens should we aim for our design for the recommendation? Can you hear me well now? Is the voice clear? Can everybody tell me in the chat if they can hear me now better? Okay. So hopefully you can read me better now, hear me better. I'll try to raise my voice. Is this better now? How about now? Can you hear me now? I'm just checking the voice first. Is now better? Okay, perfect. So we'll go, hopefully you can hear me better now. So going back to the slides, so which one did we think is the better? Okay, perfect. So which one do you think the design that we should choose? So a lot of you said left. So that's correct. So we should aim for the design on the left. So in this situation, this is a high state scenario. So the user is exercising after injury, and we want to give the user details about why a prediction was made in this high state scenario. So what we want to avoid is the one on the right. So don't say what without saying why in a high stakes scenario. So we said that in order to calibrate the user trust, we need to think about what are the stakes. So in the previous example, the stakes are high as the user is exercising after an injury. So our feature prediction will have a high impact on that user. Similar to the navigation app, when the user is heading to the airport, the stakes are higher than if they are doing a daily commute. So another component that we have to think about is the presence or lack of system data impacting the feature's confidence. So is your product feature lacking data that can lead to no trust or too much trust? So for example, if a music recommendation app claimed to cater to all music lovers, but the feature was not trained on death metal, that would easily erode trust for many users, and they will not trust your app recommendations, or they will trust it less. Another example. So say you are installing an AI-driven navigation app, and you click to accept all terms and conditions, which includes the ability for the navigation app to access data from your calendar app. Later, the navigation app alerts you to leave your home in 5 minutes in order to be on time for an appointment. So if you didn't realize, read, or remember that you allowed that navigation app to access your appointment information on your phone, then this could be a very surprising to you as a user, right? So, for instance, you could become suspicious of the app's data sources, or you could overtrust that it has complete access to all your schedule information. So, one way to avoid this is to explain the connected data source, how the navigation app knows about the appointment as part of the notification that you provide. And you can provide an option to opt out of that kind of data sharing in the future. And in fact, regulations in some countries may require specific contextual explanations and data controls. So, Selwa, is the sound still not good, or are you all good? So, back again to our running working app. So, back again to our running working app. Which one of these designs should we aim for? Again, if you know an idea, please write in the chat. So, which one of these designs should we aim for? The left or the right? I apologize for the sound. I'm trying my best. Is it now better? Okay. Hopefully now it's better. Okay, perfect. So this will be the one on the left again, right? Because it told the user when a lack of data might mean they need to use their own judgment. So the app recommendation did not include the streetlight data in their data features. So that was communicated back to the user, and the user will then know that they may use or they may need to use their own judgment. So don't be afraid to admit to the user when a lack of data could affect the quality of the machine learning recommendations, and really be open about it to your users. So the AI system should explain the following aspects about data use. First, be open to the user about the data being collected about them and used in the machine learning feature, and which aspects of their data are being used and for what purpose. Also, explain whether the system is personalized to one user or device, or if it's using aggregated data across all users. Also, tell users whether they can remove or reset some of the data being used. Again, what we want is for the user to be in control of their data and how it's connected and how it's collected and used. So just as important as system data, we need to consider the user knowledge that is being brought to the table. So if your users are subject matter experts in the feature domain, they will be scrutinizing the prediction much more heavily than a user that is not an expert, or who may end up over trusting a recommendation because of lack of prior knowledge. So I want you to think on times where you've used an app that provided predictions or recommendations. Let's say picking out a Spotify playlist. And I want you to think about the following questions. What was at stake for you personally? How clear was it that system data, the product or service relied on? And how about your own knowledge and experiences that you brought to this interactions? And how did that impact how much you trust what the product showed? So I will leave you with this exercise to think about at home and next time when you use any ML feature in the future. And these are the kind of key things that you want to think about as developers, designers, ML experts with your team when you're pushing out an ML based feature in your product. How to calibrate the user's trust. So to summarize, we first think about the stakes and ensure you communicate the why the feature made a prediction in high stakes scenario. So in the recovery workout app, our user is exercising after an injury. So we are recommending a recovery workout because there was minimal elevation, it was a low pace, and even surface. So we thought about the high stakes scenario. Also, don't be afraid to communicate the limitations, such as the lack of data to your users. So, for example, in the running a workout example, we communicated back to the user that street lamps were not considered in this prediction. And lastly, think about the users that might be using this app and how their knowledge might impact their trust. So, an expert fitness trainer, for example, using our app, might be more scrutinizing of the prediction than a non expert user that might be over trusting of the prediction. Okay, so how can you help your users calibrate trust in your machine learning driven feature then? So AI systems often generate output that the user needs to act on. So if, when, and how the system calculates and shows confidence level can be critical in informing the user's decisions making and calibrating their trust. So rather than stating why or how the AI came to a certain decision, model confidence displays explain how certain the AI is in its prediction and the alternatives it considered. So this brings us to if, when, and how should we display the model confidence for our users. So what do we mean by the confidence level or model confidence? So it's a statistical measure of how certain a prediction or outcome is. So for example, when you search for a restaurant using Google Maps, Google might recommend a restaurant based on the previous restaurants you visited before. And it might give you a score of the confidence of that prediction, which, for the example on the right, it provided you a 95% match. So when designing, if you want to display the model confidence in your machine learning feature to your users, be sure to set aside lots of time to test if showing the model confidence is actually beneficial for your users and your product or feature. So you might actually choose not to indicate the model confidence in your app if the confidence level isn't really impactful. So if it doesn't make an impact on user decision making, consider not showing it. Also think about how much granularity of your confidence score you should include. So showing more granular confidence can be confusing if the impact isn't clear. So what should I do when the system, for example, is 85.8% certain versus 87% certain? So what does that mean? Also, showing the confidence can create mistrust. So if the confidence level could be misleading for less savvy users, reconsider how it's displayed or whether to display it at all. So a misleading high confidence, for example, might cause users to blindly accept the result. So let's take a look at the various ways that you can display confidence and what we can learn from them. So let's walk through some design patterns for displaying confidence, which can be used standalone or hybrid of sorts, all depending on your user needs. So you have categorical, Nbest, numeric, and data visualization. And determining which one you want to use can also affect the type of neural network you build. So for example, if you need a model to predict a number, your last layer will have a sigmoid activation function. But if you want a more classification or multiple categories, your last layer of your model might be a softmax activation function. So knowing this up front, for example, by working with a designer and doing a user study, can be valuable to inform the design of your model. Okay, let's start with the first one, which is categorical. So categorical visualization categorize confidence values into buckets, such as high, medium, and low, and show the category rather than the numerical value. So the example on the right is from Gboard, which offers swipe typing and predictive text. So in this example, it's a bit slightly modified version of categorical, where the best match is features in the center and good matches on either side. So if you're writing in that app, for example, the word chatting, the app gives you recommendation. Do you mean chatting with a question mark, which is the highest prediction or the best match, which is presented in the middle? Or is it the other matches which are presented on either side? So there are a couple of things you need to consider here. So your team will determine, you have to discuss with your team and determine the cutoff points for the categories. How many categories do you want to display? So in this example, 3 categories are displayed. So it's important to think carefully about their meaning and about how many there should be. Here's also another example of using categorical representation in our workout app. So we were able to provide multiple running paths based on the user style, from the best match, good match, to the match unsure. So another option for confidence display is Nbest. So N here representing a certain number, like the top 1 or 5 matches. In this Nbest example, we have the Google Translate, where it suggests the most confident translations followed by other options. So it will provide you with the best result, but also provide with other results that you can consider as a user. So this approach can actually be very useful, especially in low confidence situations. So showing multiple options prompts the user to rely on their own judgment. It also helps people build a mental model of how the system relates to the different options. So determining how many alternatives you show will require user testing and iteration. So fortunately, many machine learning models already return a ranked list of predictions. This can be easy to add in from the engineering point of view. Likewise, this can also affect the design of your neural network. For example, top 1 accuracy may be relatively low, but top 5 accuracy may be high. So if you know upfront that you can design a system with an Nbest list, that also will affect the design of your system. Also, here's another example of using Nbest in the running or workout app. It gave you the best result, but also other results in the bottom. and the user can take a look and make their own judgment. Another common form of confidence display is numeric. So numeric confidence indicators are a bit risky because they presume your users have a good baseline and understanding of probability. And there are a number of considerations that you have to think about if you want to use numeric. First of all, make sure it gives enough context for users to understand what the percentage means. So new users may not know whether a value like 80% is low or high for a certain context, or what that means for them. Because most AI models will never make a prediction with 100% confidence, right? So showing the numerical model confidence might confuse users for outputs they consider to be a sure thing. So for example, if a user has listened to a song multiple times, the system might still show it as 90% match rather than 100% match. So we have to think about these considerations if we want to use a numerical score. So here is the numerical confidence, how the numeric confidence might look like in the running example presented as a percentage. Another kind of display is the data vis, and these are graphic-based indications of certainty. So for example, if the feature is a financial forecast, you might display the confidence as visualization that could include error bars or shaded areas indicating the range of alternative outcomes based on the system's confidence level. So here we have a visualization for a prediction of whether or not a kind of disease is present in the image above. But also keep in mind that the common data visualizations are usually best understood by expert users in specific domains. So if you feel your users are experts and would appreciate this kind of visualization, that's when you kind of choose that kind of display for your confidence or for your prediction confidence score. Okay, so we provided a walkthrough for a handful of these design patterns for how you can show model confidence to your users in a way that is clear and actionable. So let's try to apply what we learned in the next discussion exercise. So imagine you are building an image classifier to help your users identify the breed of a dog. For example, is it a poodle or a husky, etc. Which confidence display pattern might be most useful for your users? Would you use categorical, numeric, Nbest, data viz, or different combinations? So I want you to write what you think in the chat, and I'll give you a little bit of time to think about this exercise. So in this example, which kind of display would you use? Any ideas? So this actually is an example of a similar problem that the Google Lens team has worked on. So let's take a look at how they decided to display the model confidence for their users. So Google Lens utilized Nbest. So when a user pans their phone's camera across something, say a dog, Google Lens will show the top match, say a Labradoodle. And if the user swipes up as well, It will show the lower confidence matches, say the golden doodle or poodle. So this approach can be especially useful in low confidence situations. Showing multiple options prompts the user to rely on their own judgment. And you might decide to choose another kind of visualization, such as data viz or even categorical. It all depends on your users. It also helps people build this kind of visualization, help people build a mental model of how the system relates different options. So to summarize, here are the main takeaways from this talk. Consider how the stakes, system data, and user knowledge calibrate trust. Be sure to set aside lots of time to test if and when and how showing model confidence is beneficial for your users. To assess whether or not showing model confidence increases trust and makes it easier for people to make decisions, you can conduct a user research study with people who reflect the diverse audience that might, or users that might use your product. So for example, you might do a research study with users and ask them kind of questions like, on the scale, show me how trusting you are of this recommendation. Or what questions do you have about how the app came to this recommendation? So doing a user study will help you determine how you display the confidence score, or if you should not display the confidence score. So once you're sure that displaying model confidence is needed for your machine learning product or feature, it's important that you test and iterate to determine what's the right way to show it. So I presented a little bit about the explainability and trust that is provided by the PAIR team, but there's also a worksheet that you can look at online. And if you follow that worksheet with your team, you can kind of think about the ideas that I presented in this talk. But there are many other resources that you can use. For example, if we take the picture on the right of the cat and dog. So if we remember, we talked about how it's important that you communicate to the users of how that model or how that feature came to that prediction. And if we take the example of the image classification of whether it's a cat and dog, we want to explain to the user why the prediction was made if it's a cat and a dog. And if you see the picture on the right, the image classifier classified it as a cat. And for that, you can actually use a tool called Lime, which is an explainability tool that you can check in your own time and can highlight the regions of the image that contain evidence for a cat, here highlighted as green, and against, which is the dog, highlighted in red. Meaning, what are the features did the model use to make that prediction? There's also a paper about that titled Why Should I Trust You? Explaining the predictions of any classifier that you can read. And also the code for Lime is open source, and you can take a look. So there are also many, many other resources and frameworks on explainability in AI. I know IBM has something as well, and many companies are now focusing on this topic. So you will definitely find many resources if you search. But I think Lime is also very useful, and I'll just end this talk by presenting you with a video that kind of explains what Lime is about.
Sometimes you don't know if you can trust a machine learning prediction. Take a doctor, for example. They cannot trust a diagnosis just because a computer said so. You also need to know if you can trust the model before putting it into production. Let's say we have a machine learning system that can detect wolves. We can look at accuracy and at some of the predictions, and they may look good, but is that enough for us to really trust the machine learning system? What if you could understand why any classifier is making a prediction? Even incredibly complicated models, such as neural networks, random forests, or SVMs with any kernel. Wouldn't that be cool? It's easier to trust a prediction if we can understand the reasons behind it. Going back to our doctor, if the model told him which symptoms are important, he would trust it. It's also easier to figure out if you shouldn't trust a model. If our wolf detection system is actually just detecting snow in the background, we will not trust it, even if the accuracy is high. I said it would be pretty cool if you could understand any classifier. With LIME, you can. LIME is short for Local Interpretable Model Agnostic Explanation. Let's look at this acronym from the bottom up. We know what explanations are. By model agnostic, we mean that LIME treats the model as a black box, so that it works for any model. Interpretable means that the explanation produced by LIME is simple enough for a human to understand. Finally, local refers to how we get these explanations. LIME approximates the black box model locally, in the neighborhood of the prediction being explained. With LIME, we can explain why a random forest thinks this email is about atheism. It picks up on words such as atheism, or God with lowercase g. It also thinks that God with uppercase G is evidence for Christianity. Or why Google's Inception neural network thinks this image is a guitar or a Labrador. In our experiments, we show that these explanations help real users do all sorts of things, such as choosing between competing models, detecting and improving untrustworthy models, getting insights into the model. LIME helps you finally answer the question, why should I trust you? Thanks for watching. Make sure to check out our paper and open source release. It includes the complete source code and IPython notebook tutorials so that you can explain your own classifier.
And with that, I conclude this talk. Thank you very much for joining us. I hope you found this helpful in thinking about how you can display your model predictions to your users and how to calibrate their trust. I apologize about the sound issues in the beginning, and hopefully you were able to follow along with the slides. Please feel free to use the chat to ask the questions, which I'm happy to answer. Also, here's again my Twitter handle at Bushra AlAhmadi if you'd like to send me any direct messages or follow-up questions after the talk. So thank you, and I'll be taking some questions in the chat right now. So anyone have questions? I'll take a look at the chat. Okay, so back again to the questions. So you can contact me through Twitter at Bushra AlAhmadi through direct messages. Rami, can you please give us how to measure, firstly, the confidence of data gathered? Do you mean how well the data is, or can you please clarify your question? There are various, Reem, there are various evaluation metrics that really depend on the objective to make sure how well your model is performing. And it also depends on what's more important in your application. Is it the false positives and false negatives? So if you Google just performance measures, you can take a look. But the most common ones are F measure, precision and recall, and accuracy. So these are metrics that you can use to evaluate how well your model is. So it will give you a score, let's say 90% or 95%. And then based on that, you know if your model is doing well or not. Any other questions? So choosing the right evaluation metrics, as I said again, it depends on what the goal of the application is. So for example, if you want to build an app that determines if a patient has cancer or not, then you might really care about what do you care about? Is it the false positives or the false negatives or both? So F measure is good because it takes into considerations both the false positives and false negatives. But again, it really depends on your application and what you think is best suited for the prediction that you want. So going back to Rami's question about the data, that's very difficult, and usually trusting the data really depends on you when you build the models to kind of go through the data and make sure that you remove any noise. And that's a problem as well if you are taking a data set from someone else. You have to kind of go through it and make sure that the labeling is correct before you use it in your model. So do you recommend me a course related to trust and accuracy to start research? So trust and explainability in AI is actually a very new and hot topic. As I said, if you go to the PAIR team, there are some papers that you can take a look at. But also I know a couple of industry like IBM is also doing research in that area. So you might want to take a look at that. So we only have 2 minutes left. So to Mohammed's question, how to choose the mathematical model for the algorithm of artificial intelligence. So it depends on the kind of model you're using. Are you using a deep neural network? Are you using a random forest, support vector machine? These are various models that are deployed differently and use different kind of algorithms. So you can take a look at each. You might want to deploy use all of them and kind of evaluate against each other and to see which model works best for your data set and for the application and prediction you're using. So Rami, are evaluation matrix enough, testing and analyzing results and then seen? Yeah, so it's very important to train your model on one data set and then evaluate with another testing set that you didn't consider to see if you're able to do prediction on unseen data. So that is also another point that you take into consideration when you evaluate machine learning models. So unfortunately, I think we're out of time, but thank you very much again for joining on. And also, again, if you want to have any follow-up questions, feel free to send me messages on Twitter, and I'm happy to answer. Thank you, everyone, and please remain safe. Bye.